Starting as a young boy counting pebbles and calculating with sugar cubes, Ampere grew into the legendary Newton of electricity. Join us as we discover his incredible path of self-learning. In Lyon, back in the late 1700s, there was a very curious boy. Even before he learned to read, he tried to understand the world just by using numbers.
Andre, please take your medicine. Look, I have some sugar here to help it go down.
No, Mom, I'm not drinking it. I don't want this sugar. Please, Mom, let me have the cubes.
But you're sick, honey. That's why I took your pebbles away. You can't play right now, you need to rest.
That's why I need them. Please, Mom, let me have them. I promise I'll drink the medicine.
Oh dear. What are you doing with all these broken pieces?
I'm doing addition, Mom. I don't have the pebbles, so I'm using this to replace them.
The boy was so engrossed in his math that he recovered without even realizing it. At just 12 years old, he had devoured his family's library and knew many pages of the encyclopedia by heart. Yet, a significant barrier stood in his way.
Euler, Bernoulli, such magnificent knowledge. Why did you write it all in Latin? Fine then. If I want to understand the mathematics of these geniuses, I must learn their language. Starting today, I will teach myself Latin.
After his father's death, the family struggled. Ampere became a private tutor to earn money, but without a formal degree, his brilliance was often overlooked.
We acknowledge your talent, Ampere. But without a diploma, no university can hire you.
They can deny me a position, but they cannot halt my work. This treatise on the mathematical theory of games will be my vindication.
Mathematical genius brought Ampere to the Paris Academy. But his true destiny began in September 1820, with news that shook the scientific world.
Ladies and gentlemen, as Oersted's experiment demonstrates, when I place a current-carrying wire near this magnetic needle.
How curious. How can electricity and magnetism possibly be connected?
No! They are not separate.
What do you mean, Ampere?
Can you not see? Magnetic phenomena are electric phenomena. I must prove this. I must return to the laboratory at once.
Ampere threw himself into his work with frenzied energy. He designed an experiment to prove that electric currents could exert forces on each other.
Look, two parallel wires, currents flowing in the same direction. They attract, and if I reverse the current, they repel.
Inside the simple lab, Ampere founded Electrodynamics. He revealed a basic rule: parallel currents attract, while opposite currents repel. Ampere did not just find the electromagnetic force. He boldly swept away the old notion of a mysterious magnetic fluid.
Gentlemen, observe. A coil with a current flowing through a solenoid behaves exactly like a bar magnet. What does that mean? It means that inside this magnet, there are essentially countless tiny circular currents flowing.
So, magnetic interaction is actually just the interaction between electric currents.
Ampere was a genius, but his absent-mindedness was just as famous. Ampere mistook the back of a carriage for a blackboard. He began scribbling equations, but as it moved, he ran after it, only stopping when he realized he was chasing a vehicle. In his final years, Ampere foresaw cybernetics, the science of control. From a self-taught boy to the Newton of electricity, his legacy lives on in every device powered by the amp.